Good to go? We can even handle if there's more than one mass. Conlon, I'm going to start on the very left-hand side. So on this 1 kilogram mass, what are the forces acting on it? Get the obvious one. Is there more than one mass in this question? So instead of writing mg, I'm going to call this one m1g, pointing down. Is this mass sitting on a surface? So is there a normal force? No. Don't get normal force loopy and start sticking it everywhere. And since there's no normal force, no friction. Okay. Oh, what else? A rope. What have we called that force? Pause. See this rope? See this rope? Is there more than one rope? Is there more than one tension? So I'm going to call this tension 1 in my high-tech system. Is that okay, Jordan? So I'm going to go T1. Those are the forces acting on this mass. I'm going to come to the middle mass in a second. I'm going to call that mass 2. Let's do the right-hand mass. What are the forces acting on it? Get the obvious one. And I'm going to call that right-hand mass, mass 3. What else? Is that a different rope? I'm going to call it tension number. Yeah. You okay with that? Let's do the middle mass, mass 2. What are the forces acting on it? Get the obvious one. I totally agree. Is it on a surface? Is it sinking into the ground like quicksand? Is it flying into the like Superman? So there's going to be a normal force, and you know what? I'll call it normal force number 2 to go with mass number 2. You know what, Conlon? I forgot to ask you to read what they're asking me to find. What are they asking me to find?
Acceleration
and
tension in both courses.
Okay, we're going to find acceleration first, and then we'll look at individual masses to find tension. Okay. What else is on mass 2? Are there ropes? Let's deal with those. I think I'm going to have tension 2 to the right. It's getting tugged that way. I think I'm going to have tension 1 to the left. It's getting tugged that way. I think I did my directions wrong for you guys. Is there friction? How do you know? Can you be more specific? Because I know it says, for the people at home or watching, what says that up there?
So the 0.25.
What symbol do we call that?
Mu.
Hey, what's mu? I don't know what's mu with you. Okay, so there is friction. Not much. All right. Which way? Well, how big?
1 kilogram.
How big?
8 kilograms.
Is this going to slide down and pull this up? Or is this going to slide down and pull this up? Which is the bigger mass? Okay, can you agree with me, Mina? The 8 kilogram is much larger than the 1 kilogram. It's going to yank this one down and lift this one up, which means which way is this going to slide? To the right or to the left?
Right.
Which way is friction going to point then? To the?
Left.
Yes. See how we put that together? Is that okay, Josh? Okay. Getting a little crowded. I'll put it right there. Friction. And I'll even call it friction force number 2 to go with mass number
2.
just to be organized. Casual, you okay with that? Folks, have we missed any forces? I don't think so. And really, Raven, all I can do is add extra forces, which makes the equation longer, but I'm going to argue not really difficulter, more difficult. Ready? What's the first thing they wanted me to find?
Acceleration.
We're going to do that by writing an equation for the whole string. We're going to write an equation all, come on. We're going to write an equation like that. That's going to be our equation. Who's winning? What's causing this whole thing to accelerate in the first place?
The 8 kilogram.
What force from the 8 kilogram thing? Can we use more nouns and less pronouns? What particular force on that there 8 kilogram on mass 3 on that diagram? What force? Look at my free body diagram. Which is the force that's winning? More specific, can you read me from my free body diagram how I've labeled that specific force by using 2 letters and a number? Okay. That's what I'm looking for next time right away, okay? Don't give me any, just let's go be very specific. What force is winning?
M3P.
So anything that ends up pointing down when it gets to this side is going to be winner plus. Anything that ends up pointing up when it gets to this side is going to be a loser minus. Okay? Follow me? All right. M3G. Now let's walk along the string. I run into this tension 2. This tension 2, winner or loser?
Loser.
Yeah, so minus. because of course being a loser is such a negative thing. This tension 2, if I follow it, and I have to use my imagination and then bend it around the corner, when it gets here, I think it would end up pointing down, winner plus. Am I going to include these two forces? Are they along the string? So don't put them in my equation. They might show up in other ways, but they're not going to show up in my equation right now. Oh, tension 1. Now it's pointing to the left. If I follow it all the way as it bends around, I think when it gets to here, it would end up pointing up. So that makes it a.
Loser.
So in front of it, I'm going to put a.
Minus.
Thank you. What about friction force number 2? Winner or loser? Yep. Okay, keep going, keep going, keep going. See, this is an interesting one here. Tension 1, you might be saying, oh, it's pointing up, it's a loser. But if you follow it when it bends around this corner, now it would be pointing to the right. And then when it bends around this corner, I think it ends up pointing down. I think this tension 1 ends up being a winner. Is that okay? Got to use your imagination a little bit, Jordan? Does that, you can follow that? You guys have played enough video games that you can kind of go around corners and things? Okay. And then this M1G, again, you might say, well, it's down. You said down was a winner. But I think if you follow it, when it turns the corner, now it's pointing to the left. When it turns this corner, I think it ends up pointing up when it bends around this corner. So I think it ends up being a loser. You okay with that? And here was the only tweak we said. We said if you give me more than one mass, do I have forces from more than one mass on the left-hand side? Say yes. Do I have forces from mass 3 and mass 2 and mass 1? Then I better have mass 3, mass 2, and mass 1. Don't write this down, don't write this down, don't write this down. I would have no problem, Conlon, if you went, don't write that down. But that's a lot of writing. Raven, I'm lazy. If you want to, you can write that, or you can go the mass of all of them times A, which is less writing. Write that down. But it's got to be equal to MA. Zach, I don't care which approach you use, right? Conlon, stick your left hand into the air. Stick your right into the air. Stick your right hand into the air. Stretch, come on, stretch. Oh, this is so relaxing. Conlon, why are we so relaxed?
Because we lost tension.
We lost tension twice? So you ready? Here's the worst joke of the year. Are you ready? We have attention deficit disorder. we have no tension. It's attention deficit disorder. Oh, come on! That was pretty good! No? Oh, man. I thought of that yesterday, and I'm telling you, that's going to be in my teaching for the rest of my career. It's a tension deficit, and we need to find tension later on, so it's a tension deficit disorder, because we'll need to find... Oh, man. Nothing, Aaron? Nothing? Really? Okay. Conlon, let's keep going. What were we trying to find first?
Acceleration.
How would I get the A by itself?
Subtract.
What's the A doing to the M? What's the M all doing to the A? Adding, subtracting, multiplying, or dividing?
So divide.
Divide. Don't make that, I'll call that a mistake, a sloppy mistake. Don't do that, because then everything else you do after that is going to be ugly, wrong. Okay. So if I hear you, you're telling me the M3G would drop down like a domino. By the way, those that were away yesterday, I didn't point out, the reason the tensions cancel is you have a minus T2 plus T2 gone, you have a minus T1 plus T1 gone, and that'll happen if you set it up right. And the joke I make is, I love losing tension. I find these questions really relaxing. These are like little mini spa treatments because I always lose tension. I have a tension never mind, okay. Minus friction force number 2. Minus M1G, you said I'm going to divide that by the mass of all of them. And do you mind, Conlon? I'm going to put the A right there. Okay? Before I go further, I'll do a quick check. Conlon, do I know mass 3?
Yeah.
What? 8? Right? Okay. Do I know G? 9.8. Do I know friction force? Ooh. I don't think I know this yet, so I can't start plugging in numbers yet. Apparently, I have to do something with this. So let's rewrite what we have. I'm going to put an equal sign. I'm going to scroll down so it's higher. You guys have to give me numbers if I need them. It's M3G minus friction. Oh, let's put it all together. Friction is what times what? Raven, loud and proud. So friction force number 2 is going to be mu times normal force number 2. That's why I labeled them that way. I do have a normal force number 2 up there, right? I'm doing that because eventually you might have 5 or 6 masses and all. Okay, be organized. So it's going to be mu normal force number 2, and then there's still a minus m1g. Don't forget to rewrite that. And it's all over the mass of all of them. I'll do my quick little check again. Conlon, do I know mass 3? Yeah. Do I know G? Yeah. Do I know mu? What's mu?
0.25.
I don't know. What's mu with you? Okay. 0.25. Do I know normal force? Yeah. I don't know the normal force number 2. Oh. But look. I know another force the same size as normal force number 2. What?
Gravity.
Which one? I got 3 in my equation. Be specific. Please read forces specifically by using letters and numbers, please.
M2G.
Yes. Okay. I jumped on that, but I got 3 gravity. Which one? Okay. So, if I hear you correctly, you're telling me it's going to be M3G just dropping down like a domino minus mu, and you said it was M2G, and then minus M1G also drops down like a domino. And now instead of M all, I'm going to write M1 plus M2 plus M3 because that's what I'm going to do. Do a quick check. Do I know the values of every one of those? I did a quick check. Yeah. Now we can go to the plug and chug stage. This is pretty hefty. I'm going to insist that every one of you gets out a calculator. I'm going to insist that you have a calculator. If you don't have a calculator, I'm going to swap you your phone for a calculator because phones are not acceptable. Mr. Dulac? Yeah, Bryce? Do I have to show every one of these steps? Bryce, I would on a test, just because you don't want to make dumb mistakes. I'm okay if you are comfortable going from this line, friction force number 2, to saying in your head, it's mu times the normal force. I don't know the normal force. Oh, but look. I have no problem if you kind of skip this intermediate line. But these are complicated enough. Hopefully you've picked up, Josh, I love shortcuts. This is kind of where I stopped taking shortcuts. It's way too easy to make a mistake. So, Conlon, let's finish this out. How big was mass 3?
9 Oh wait, that was 8.
Which one? 8? You sure? Okay. I know G is 9.8. Minus, what was mu? 0.25. How big was mass 2?
9.
That's 9. 9.8 minus mass 1 was, oh, that I got on my screen still, 1. 9.8, all divided by 1 plus 9 plus 8. Of course, Conlon says this is a fraction, so around the top, what are we going to put? And around the bottom, what are we going to put? Try typing this in. Oh, what was the built-in error check for these questions? What's the biggest the acceleration can possibly be here? Remember? 9.8, because that's what, if I cut this rope, this guy would accelerate at 9.8. So he has to be accelerating less than that because he's dragging all this other stuff. So if you get an answer bigger than 9.8, you've typed it wrong. Right? Raven's looking stunned. You've typed it wrong. But I do like that there is a built-in error check that isn't too tough for me to remember. Alrighty. Eight times 9.8 minus 0.25 times 9 times 9.8 minus 1 times 9.8. I probably didn't need to type the 1, but I'll put it in there anyways. Divided by or close bracket, divided by bracket 1 plus 9 plus 8. If you added that together in your head and just put an 18 there, I'm fine with that too. And I get 2.58611. That?
Yep.
Yeah? I'm going to write 2.59, but I'll keep this on my calculator. Final units. Conlon, acceleration. There you go. I don't think I'm going to give you a 3-mass question on your test because, Mina, it's just too much writing. I'm absolutely going to give you a 2-mass question on your test. In fact, probably more than one. But for what it's worth, Mina, could we handle 5 masses? Sure. It'd be a longer equation. Could I handle 8 masses? Sure. Be a longer equation. Oh, and on the right-hand side, it would be the mass of all of them times A. Okay. We're not done. Zach, what else did they want me to find? There's 2 tensions. So I have enough room. I'm going to draw a little line like this. I'm going to find tension 1 on the left and tension 2 on the right. Which mass would I not want to use? Which mass has all sorts of junk on it and would be tricky to try and find tensions with? I'm not using M2. Okay? I'm going to use M1. And which tension can I find from mass 1? I guess tension 1. I'm going to use mass 3. And which tension can I find from mass 3? I guess tension 3. And then I'm good to go. So, Jordan, my angel, see mass 1? Which way is mass 1 accelerating, up or down? Remember how we've handled this whole thing. Who was winning? Way over here, right? So this is going down. So which way is this one going? So you ready? Which way is accelerating? Say it again, loud and proud. Who's winning then? Which way is accelerating? Up. So who's winning? Up. What? Who's losing? Okay, so our equation for tension 1 is going to be tension 1 minus M1G equals, now it always is winner minus loser equals MA. Which mass are we looking at for this one here? So it's going to be M1A. How would I get the T1 by itself? How will I move that minus M1G over? Yeah. Are you cluing in why I said this formula manipulation thing is the way to go? You can't memorize every possibility. So tension 1 is going to be M1A plus M1G. How big was mass 1? Was it 1? M1? Yeah. Okay. And A, I'm going to use my answer button, so 2.58611. 2.58611 ... plus 1 times 9.8. Okay. 1 times answer button plus 1 times 9.8. Tension 1 is 12.4 newtons. Yeah? Okay. Mina, my angel, let's look at tension 2. I'm feeling some tension right now. Don't worry, it'll all vanish. Mina, looking at tension 2, mass 3, this mass here, which way was this mass accelerating, up or down? Down. Who's winning? Which way is this accelerating? So which way is the winning direction? Give me the same answer. So who's winning? Yes? Who's losing? More specific than that guy. Thank you. Got it all together? So our equation, I think, Mina, you said is going to be winner M3G minus T2 equals, Mina, winner minus loser always equals MA, but what mass are we looking at now? Mass number. So it's going to be mass number 3 times A. What are we trying to find, Mina? We're trying to find tension. What's right in front of the letter T that I don't like? Oh, we can plus. We've done this dance before, you and I, yes? I'm going to plus it to that side, draw a little arrow pointing that way. And at the same time, Mina, I'm going to minus that to that side. I'm going to get the M3G dropping down minus M3A. That equals tension 2. Tension 2 is going to be, I've scrolled down. Mina, how big was mass 3 from the diagram? 8, thank you. How big is G, folks? 9.8 minus 8. And the acceleration was, now I can't use my answer button. I can see mine. I'm going to write 2.58611. That should be pretty accurate. 2.58611. Eight times 9.8 minus 8 times 2.5861111. I get. Is that right? By the way, so 57.7 newtons. Which rope is more likely to break? Yeah, second rope. Has to be a stronger rope for this to work. Okay. What's your homework? I'm going to give you a take-home quiz, but you can try. I think you're going to have to do your free body diagram here, but I think you'll have to do the equations on a separate piece of paper unless you write ridiculously microscopically small. So I would advise doing the work on a separate piece of paper, but don't bother trying to copy out the diagrams. You can if you want to, but I'm fine if you do your free body diagrams on these pictures. So you can do number 1, number 2, number 3, number 4. You know what? Cross out 4. 5, 6, 'I'm going to give you 7. 7 is tricky. I actually stole this from Physics 12. In particular, it's asking you to find a coefficient of friction between the 2 kilogram mass and the 12 kilogram mass. Right there. If you can figure that out, I'll be impressed. So if you find that one tough, I won't freak out. 8 is fair game. 8 is just like the one we did, complete with friction, except the 12 kilogram mass, I changed the numbers. What's number 9 asking me to find? Hey, what's mu? I don't know what's mu with you. So in number 9, you're going to get the mu by itself at the very end. What's the acceleration of number 9 if it remains at rest? 0, which means you're actually going to end up going winner minus loser equals 0, which makes the equation way easier. Compare that with number 10, where we are accelerating, which makes this much tougher. I haven't done one like that with you. Number 12, this is from an old Physics 12 scholarship exam. Again, I'm not going to give you one this tough, but if you want a challenge, if you want to see if you can figure out a nice puzzle, this is really a nice little puzzle. Here's your take-home quiz.